This is the pre-lab lecture for experiment 6. As the pattern has been, just remember that the pre-lab data observations are due on the day of the experiment. That's April 29th. Quiz 3 will open then as well, so I'm going to take quiz 3 starting on the 29th. But as you know, this is lots of experiments out there. You still have a post-lab for experiment 5, and then the post-lab for experiment 6 isn't due till May 11th. So if you have questions over any of these, come see me during office hours 12:30 on Zoom. Please note we're getting closer and closer to the big experiment. Experiment 7 is 100 points. So actually this experiment in particular talks about techniques leading to experiment 7. So this will be a good time to review some of these concepts. If you're thinking of withdrawing from the course, let me know. That date is 5/8. You have to be withdrawn by that date. So today what we're going to talk about is just a little bit about the reactions you're going to see, what you need to observe, and then we're going to talk quite a bit about the quantitative aspect of this experiment, which is the titration. So there's several videos. You need to watch the videos and think about, imagine how you would do this if you were in the lab. So our schedule coming up, experiment 6 is on Wednesday, and then the following Monday is activity 13, and then the big experiment starts on May 6th. So a couple of things that I want you to be aware of. First, just like before, I know this isn't a replacement, but these videos mimic what actually happens in the lab. So make observations based on those videos. You don't have to worry too much about volume or concentration for the first part, because this is all qualitative. Okay, the question is, what happens with calcium when you put it in HCl? What happens with calcium when you put it in water? Same with zinc. Okay, so that's what you're looking for on the first part, is the qualitative. And if we were in lab, I would really point out and emphasize that there are 2 bottles of HCl. One bottle says 6 molar of HCl, and actually sometimes in the past it'll say 6 molar HCl. So there's not a lot of sig figs here. It's just saying, you need some acid and react it with these metals. That's what you're looking for. So you're going to see some great reactions. You saw actually the experiment 1, the reaction of iron with hydrochloric acid, and it produced hydrogen gas. And it was so disappointing to most of you because you tried to ignite the hydrogen gas and there was no pop. Well, if you were in this lab doing this lab, you would produce a lot of hydrogen gas. There'd be great pops all around the room. It'd be fantastic. So watching the video is definitely not a replacement for that, but this is the observation you want to see. Does hydrogen gas form? Can you confirm that by hearing the pop? The indicator will also tell you if the solution is basic, if it goes pink. So you're looking at an indicator to see, do we have some bases being formed as products? So that's the first part, qualitative. The second part is the quantitative piece. Okay, so you're taking the specific reaction of calcium and water, and you're assuming you don't know what forms, okay? So this even says the calcium and hydroxide. So what we're trying to do is suspend what we know, okay? If you know the formula, calcium and hydroxide, you probably know what goes here at the subscript. But what I'm telling you is suspend that. Don't know what X is. You're calculating X. How this has hurt students in the past is, well, they say, well, I know what X is. X equals this, and you don't do any calculations, and you miss a whole section on the post lab, okay? So we'll go through the calculations, what you need to do for that. You can see in this part, look at the hydrochloric acid, 6.183 molar. That's 4 sig figs. That definitely tells you a difference between, that's qualitative, this is quantitative. So you're given the data in lab archives. So use that data as you complete it. Imagine that you completed it in our lab. This is previous student data, so this is good data that has come from our labs. And as I mentioned, experiment 7 is the big one, and this titration calculations, this titration concepts prepares you for that experiment. So if we were doing this in lab, I would actually demonstrate the whole thing to you. I would get up, show you the burette, show you the setup, show you how to rinse everything, how you're ready to go. We can't do that here, that's why you have the videos to see this, but I can go through the calculations, and I would do this as well if we were in lab. So what happens is you take a piece of calcium and you add it to water, and then you're going to react that product with hydrochloric acid. Okay, so this is, remember, the concentration of the hydrochloric acid. And the goal is to find the ratio of hydroxide to calcium. That's what we're looking for. Okay, so the first thing we want to do is, if we've got grams, then right away let's go to our moles of calcium. So we get our molar mass, and we can get our moles of calcium, which is half of this ratio that we need. Okay, so here, remember your balances go to 3 decimal places, so that's grams, molar mass. We got as many decimal places usually as we want, and we can get to correct sig figs. That should be 3 sig figs, and that's 0.0189 moles of calcium. Okay, so that's moles of calcium, and remember we want ratio of moles of hydroxide to moles of calcium. So the titration starts out, as in the video, murky blue. It's really an odd looking solution, and it gets more and more clear. The cloudiness, the precipitate reacts, and then you get this nice distinct yellow color that you want to hold. So that's your endpoint. Okay, so that's where you stop. You read the volume before you started, so in this case 2.73 mils. You read to the hundredths place for the burette, read to the hundredths place for the burette. So then you can calculate your volume of HCl. So this is your total HCl that was added, and that's 5.76 mils. So we have volume of HCl and we have moles of calcium, but we still need moles of hydroxide. So if we go over here, we can say, well, I also have molarity of HCl, which molarity is moles per liter, so that's a metric conversion. So that's 1,000 mils per 1 liter. And now our molarity, remember, write capital M as moles per liter. So now this is, whoops, that's 6.183 molar per 1 liter. So now our liters cancel, our mils cancel, and that's moles of HCl, which basically moles of HCl is saying 1 moles of acid, which is the same thing as saying the equivalence point. The net ionic equation would be 1 mole of H plus for 1 mole of OH. So if we know our moles of HCl, we know our moles of OH minus, and if we look here, that gets us to 0.0356. Okay, and remember, what's the goal? Again, we know the answer, possibly, for the ratio of hydroxides to calcium, but we want to find it from the calculations, find it from the experimental work, and now we can see that the ratio here, moles of hydroxide to moles of calcium, 1.88. And again, as I alluded to, you probably know, because hydroxide is a -1 polyatomic ion, this is the formula. So if you turn in and say, well, the ratio is 2, no, the ratio is 1.88 in this experiment. Okay, we want to know what's the quantitative calculation from the data in the lab, not just, oh, because I know the charges and that's how you put them together. Okay, so this is what you're going for, doing calculations based on that, and then you're definitely taking the qualitative and quantitative and interpreting what that means, what's happening here. So again, just a reminder, really encourage you, come see me in office hours if you want to talk about this experiment, because this gets you ready for experiment 7.